Hi students, myself Jagdish Chaudhary. I am going to discuss today electrostatics topic which is very important for NEET and JEE, of course for IIT Advanced. So please try to understand whatever the basics I am going to teach and whatever the techniques I am going to teach. Please concentrate when I am teaching. Just after that you please write down what you heard, understood, and practice every day. And till now my experience is like 15 years experience, and my best ranks all over India, below 10 also there, and first rank 2 times I got, means my students got, even state ranks. So please try to understand and practice. So please, happy practice to all of you. So let us start the session now. Electrostatics is the first chapter, and before handling electrostatics, let me highlight the chapter heading first of all. So start then. So listen, chapter heading is electrostatics, and now coming to the point, this proves that this is nothing but electron. This is nothing but electron. And the meaning which you call it as statics. Statics means, stationary. What does it mean? Stationary. Exactly speaking, rest. So we are dealing in this chapter only about the electrons. Once again, only about the electrons which are at rest. You may think, sir, current. Actually, the meaning of current is not a current. Current means flow. Remember that. So, when I talk about current, means when the flow taking place, means when the electrons are in motion, that is called as current electricity. The second chapter of the second year part. So, slowly and steadily we will understand the basics. So, but along with the basics, you read the topic. Clear? So let us start. So electron, electron charge. Everybody know charge of an electron is? Charge of an electron. Charge of an electron is absolutely minus 1.6 into 10 power minus 19 Coulomb. Charles Augustin Coulomb, the scientist's name. In his honor, they kept the name as Coulomb. Fine then. Maybe you have a rough idea. What is the mass of an electron? What is the mass of an electron? Yes, mass is 9.1 into 10 power minus 31 kg. 9.1 into 10 power minus 31 kg. This is how the fundamentals has to be learned. Okay, done? Yes, as I said, myself Jagdish, my name, yes, electrostatics, and I reveal the secret why the name kept as electrostatics. So in this chapter, electron, if you take, this should not move anywhere. If I drop the electron here, it should be there. It should be there. If you find out, sir, the electron is in motion, wait and see, stay back. See, as per coronavirus, it's keep on moving. That is nothing but flow. That is nothing but current. But you have to be quarantined. You should be in rest position in your home. So like that, electrostatics, electron must be at rest. Must be at rest. Clear? Must be fully quarantined, packed. Simply stay calm and see, watch. That's all. So let us extend the topic. So, people will ask you, we are talking about charges. What is the use of charge then? Of course, you have to understand once again. What about charge? Basically, some people will say that it's a property of a body. Yeah, of course, I do agree. But not always, because chargeless bodies also exist. Best example, neutron. So let us start. What do you mean by charge? Charge is the property of a body. If I say like that, charge is the property of a body, that was completely wrong, because myself Jagdish, so wherever I go, it should be Jagdish only. So if I say charge is the property of a body, yeah, for every body charge should be there then. Like my name is Jagdish. So what I mean to say, every body, it is not compulsory to have charge. It is not at all compulsory to have charge. Hence, we can define the charge like this. Remember, coming to the topic, this is charge. And this is which is at rest. Yes, we already discussed. Now come to the definition. So please listen carefully. We will talk in depth right now onwards. So charge, it is a source. So many people, when I am teaching since from around 18 years, those people come from some other medium suddenly into English medium. They don't know the meanings. So first let me explain the meaning of source. Daily we are getting sunlight. Of course, the source of light is nothing but sun. From where? From where that was producing. Clear? That is called as source. Okay, done. A source of electric field, a source of electric field. Magnetic field, a source of magnetic field, electric field, and electromagnetic radiation. And electromagnetic radiation. So once again, let me repeat it. A source of electric field, magnetic field, and electromagnetic radiation. Clear? A source of electric field, magnetic field, and electromagnetic radiation. That means electric field, the mother of electric field is charge. The mother of magnetic field, contradiction, may occur. Some people will say, sir, I have a black piece, like this. I have a black piece, sir, magnet is there. Yeah, of course I do agree. Earlier days people believed that magnetic field is existing only and only when magnet exists, only and only when black piece exists. But later on, Ampere, Maxwell, Faraday, these are all the scientists. First of all, hats off to them. Because of those people, we are using all, like AC, like refrigerator, like television, right? So we must thankful to them first of all. Clear, all of you? So then people came to know that magnet is not compulsory. See, nowadays you people are sitting at home. I am in the campus. You people are sitting at home. It is not compulsory to come to the college because of Corona, right? Because of Corona effect. So, but earlier it is mandatory. Everybody should sit in the class. But day by day, tomorrow what will happen? Next minute what will happen? Nobody says. So miracles happened in those days. People argued with Ampere. How can you produce magnetic field without this black piece? Then Ampere slapped them with his subject in the chapter Moving Charges and Magnetism, which we are going to see right now. Sorry, after break we will see. Clear? Then first let us continue about electrostatics. Yes? So charge, a source of electric field, a magnetic field, and electromagnetic radiation. So the mother of all these things is the charge. That's all the definition. Clear, all of you? But we are very much interested in the discussion of electric field. Because look at here, charge can be, small charge can be represented by the symbol small q. Clear? And this is absolutely the mother of all. But try to understand, I make you very clear. Charge, you can see here, yes, what is this letter? This letter is absolutely capital E. What does it mean? It means that it will produce electric field. It means that it will produce electric field. I understood the symbol. You're waiting for the symbol. Yes, that is E bar. Slowly and steadily we will go forward. So no matter, don't think further and further. Read, just concentrate. Yes. But what about the other line? Other line is about magnetic field. That is B bar absolutely. Clear all of you? Advaita? Okay, fine then. So now, next line. This is the final touch up. Actually in your second year, first part is electricity. And this was the last chapter. Electromagnetic radiation. Yes. Now, as I discussed, charge is the source of all these three. You believe it or not, you will enjoy the upcoming topics because they are particularly in order. Yes. Charge. Electric field will produced only when charge is at rest. Electric field is produced only and only when the charge is at rest. Remember this. And magnetic field is produced. Guessing? Yes, absolutely correct. Magnetic field is produced when it is in motion. Yep. Now, please think of it. Motion, yes, I can walk, but at the same time I can accelerate, right? So accelerate means what? My speed can increase. So motion, this is when velocity is constant. When velocity is constant, absolutely. Now, this is also in motion, but when acceleration is non-zero. Please try to understand. Once again I am saying, this one, when acceleration is zero. When acceleration is zero. But, doesn't mean it is at rest. Velocity is constant. Clear? And this one, when acceleration is non-zero, it should have acceleration. So topic by topic, in depth, we are going to see right now. So this is all the basics of electrostatics. I hope it was crystal clear. Right? Just think of it. Just put your eye for 1 second. I'll get back to you. So there is a wonderful explanation in the third part. If you see electromagnetic radiation, maybe you know about microwave oven. Maybe I am saying in that microwave oven, maybe a charged particle is accelerating like this to and fro motion. So that, as I discussed, when any accelerating particle is accelerating charge Q, then it will produce, because charge is a source of electromagnetic radiation. So it will produce damn sure electromagnetic waves, which people may call EM waves. Maybe in your school level you had been studied radio waves, microwaves. Gotaita? Microwaves. Yes. So maybe it will produce microwaves in this. In this charge is oscillating and it will produce microwaves. So that wave, that microwave will cook the food. That's all. So that is why microwave oven. I hope you understood. Okay, now we will talk about the unit of charge. You can see about the unit, SI unit, coming to SI unit. This SI unit is Coulomb. Charles Augustine Coulomb, represented by the symbol capital C. Mind it, it's capital C. Symbol, not the unit. The symbol of the unit is capital C. So whenever in exam they are asking unit, you should write the full name. Clear? Like meter, that is unit. M is the symbol. Fine then. So now, converting into CGS, 1 Coulomb is equal to 3 into 10 power 9 ESU. People ask me so many times, sir, how can I memorize? Of course, it is very easy and pretty easy. You can see, if I write this C only, if I write this small c only, then of course, this is 3 into 10 power 8 meter per second. So this is a velocity of light. Wow, velocity of light. The speed of light is 3 into 10 power 8 meter per second. But right now our topic is about charge. Yes, capital C and 1 Coulomb, so raised by 1, 9, and this is perfectly ESU. Yes, doubt. ESU is electrostatic unit. Hope so understood. Electrostatic unit. And this electrostatic unit is also called as Franklin. This electrostatic unit is also called as Franklin, which is the scientist's name. In the honor of him, they kept the name as Franklin. The symbol Fr. Symbol is Fr. and this is the smallest unit. This is the smallest unit. This is the smallest unit of charge. Mind it. ESU, Franklin, is the smallest unit of charge. Is the smallest unit. Hope so understood. Is the smallest unit of charge. Copy down. Yes, we will continue along with the units right now. 1 ESU can also be stated as 1 stat coulomb and of course, which I said, this is nothing but Franklin, right? And one more line. That was the smallest unit. What was the biggest unit then? But beforehand, practical units are there, which are 1 ampere hour is equal to, listen carefully, 1 ampere hour. 1 ampere hour is equal to 3600 coulomb. 3600 coulomb and 1 Faraday One Faraday is equal to 96,500 coulomb. Wow, such a great number, which is almost equal to 1 lakh. So 1 Faraday is equal to 96,500 coulomb. So this was the biggest unit. Whereas Franklin, as I discussed, Franklin is the smallest unit, and this Faraday is the largest unit. Remember, for 2 marks questions or for objective level, they may ask you which of the following unit is the smallest unit. Obviously Franklin. People will put charge and all, but whenever you are studying, okay, any unit, centimeter belongs to CGS, meter belongs to SI system. Like that, every unit, whatever you are going to read, you must know in which system it belongs to. So this is the largest unit and this is the smallest unit. That's all about the units. So we will continue, move on to the next topic. Yes. Now we are talking about the building blocks of the entire chapter, which are called as properties of charges. So mind it, These are all very, very important building blocks, right? So let us start then. Properties. Okay, so before handling the properties, let me tell you a few basics. So my intention always, you should learn basics first, then we will continue, because everybody born directly they won't eat rice item or chapati item. Mother feeding is very important. The same way, basics helping you a lot. Remember, put the heading basics. Mind it once again, whenever in future also, whatever may be the subject, if you are just feeling tough topic to read, first you put an eye on where you are lagging. From there you put up the basics, take the basics out, then you will concentrate on that basics. Obviously, damn sure everything will be easy. So please try to understand. So let us start then. Basics. Everybody know about atom. So here itself it is there. ATOM. I know the spellings. ATOM. Atom. Atom is the smallest indivisible particle. Yes, for your better understanding, let me write. Atom is the smallest indivisible particle. What was the size? Yes, maybe you can't see that. So for that reason, I am going into the microscopic level to zoom it out. So I am zooming it out, listen carefully. This is the nucleus. This is the nucleus. In your school level you had been studied. And around the nucleus, you know orbits, where the electrons are revolving in circular orbits, right? The electrons are revolving in circular orbits. Yes, perfect. Correct? So it is so crystal clear. So electrons are the responsible persons or the responsible items. In the earlier days, people thought that the flow is taking place due to protons in the earlier days. Then people came to know later on, reality, electrons are moving. That is why the respect gives to the chapter heading electrostatics. Yes, and you know inside this the charge is Ze. Nucleus charge is Ze, you know that, correct? And if you want to remove an electron, the outermost electron is free to remove. And of course easily you can remove, because the innermost, if you go through innermost, you are tightly bounded, and the proton to remove out, that is very energy lost process, because protons are strongly binded with a strong nuclear force, which you had been studied in physical lesson fundamental forces in nature. A strong nuclear force is the strongest force in nature, undoubtedly. Undoubtedly. So, we can remove the free electrons by providing a certain booster. Like people, Sachin used to say, now Dhoni used to say, boost is the secret of energy. So that boosting we are giving, it doesn't mean we are giving boost. Understood? So here we are giving extra energy, maybe with the help of battery. Clear? From external agency, we are giving energy to the electron to remove it out. Then obviously this free electron will come out and play a major role. That is why the current, that is why the online, everything is going on. Yes, the flow of electricity did everything for us. Yes. So let us start. The basics got over. If we are capable to remove the electron, then we can enjoy with the electron, we can play with the electron, but don't touch the electron here. Yes, done. So let us see now properties. ಗೊತ್ತಾಯ್ತಾ? ಅರ್ಥ ಆಯ್ತಾ? done. Just copy that. Let me write here. These properties are building blocks These are building blocks of entire lesson. Mind it. Clear? Yes. The first one, charge is, the first property is charge is quantized. Charge is quantized. So what do you mean by quantized? Quantized says that integral multiple of charge of an electron. Remember, anywhere, either in first year or in second year, you may read that Bohr's quantization principle in chemistry. Of course, you are going to read in physics as well. Of course, you studied in school level as well. Quantization means it is integral multiple. This is what? Remember, this is a positive integer. Positive integer, it doesn't mean it is 1.5, which is ruled out. Integer, to pakka, it should be integer. No more decimals. It should be a digit, which is positive integer. Matlab greater than 0. Understood? Yes. So charge is quantized can be symbolically written as Q is equal to NE, which can be positive and negative. How come? You know, this was first introduced by there are two types of charges, positive and negative charges. There are two types of charges, positive and negative. You know who discussed about this first time, which I already discussed. Any idea? Yes. The answer is Franklin. Benjamin Franklin. This is the reason why the people kept the name 1 ESU is equal to Franklin, in honor of him, smallest unit of charge. So there are two types of charges, and charge is quantized, and n is an integer. But mind it, in your campus around 3,000 students are there. I can't say 1.5 student is there. So obviously students are quantized. And in your campus, number of benches. Yes, in this room 1, 2, 3, 4, 5, 6, 7 approximately. No approximation, pakka, because this is a number. So, right? 12 benches are there. Quantized. 12 multiplied with one bench. So where 12 is a positive integer. If you study well and if you produce, maybe this branch will become 100 branches. That time we can't use Q is equal to NE. How come? Why? The reason behind that is, my physics teacher taught me a story. Like, this is a sweet corn. Feel that? This is a sweet corn. Sweet corn. How many corns are there? Yes, if I take it out and if I count roughly around 600 or 800, okay, fine then. Then total number of count is n times of this. Yes, like that charge also can be counted. But if I talk about truck of grains of corns, tell me, like this, so many corns are there in my hand, 100, and I ask you to count. How can I? So roughly I can say 1 crore. Yeah, if you have any doubt, you can count. People will laugh. So that time, minded extension of the topic, we have to call in terms of density. In terms of density. Clear? Like Davanagere is a big one, but Hubli Dharwad is big one, but Bangalore is very big. So we can't say about the population, we can say about the density. 1 person for square meter. So we have to talk about densities. Whenever I say a small charges, okay, you can go for Q is equal to NE. But when I say a long stick is there, on that charge is placed, how many number of electrons are placed? No. Even God cannot count. Even He will also say that density, charge by length, or charge by area, or charge by volume. So of course we will get on to that as early as possible. So we will see now. I think so till here you people understood. Clear? And in question paper they may ask you, by providing some charge, will it exist or not? So let us see that. Given question is Q is equal to minus 1.6 into 10 power minus 13 coulomb. minus 1.6 into 10 power minus 13 coulomb, and they will ask you straightforward in board level, will this charge exist or not exist? So first of all, students will think, how can I? They already got the charge. No, they are assuming this charge and they are asking you whether this is existing or not. Yes, of course. Cross check it out. How come? Yeah. In your golden hand, you have a brand rule, which is law of quantization, plus or minus NE. Yes? Say yes. Absolutely. Now, so it is minus, so don't concentrate on plus. So 1.6 into 10 power minus 13 is equal to minus n times of electron charge. I am keeping here 10 power minus 19. Yes, I have to find the value of n. Yes, you are right. Absolutely. So then minus gets cancelled. Minus gets cancelled. 1.6. Yes, absolutely correct. And this 10 power minus 19 comes to this side. Yes, it will become 10 power minus 19. Right? Of course. Or 10 power minus 13. And now, what left? N. What left? 10 power 6. Yes. Yes. N is equal to 10 power 6 is an integer without any decimal. Without any decimal. Please try to understand. If I talk about the charge like this, 1.6 into 10 power minus 21, then which is equal to n times of 1.6 into 10 power minus 19, then answer will be n is equal to 10 power minus 2. Then this is equal to 0.01, which is not possible. Why? N is not a positive integer. Mind it. Here n is an integer. This is how the cross checking should take place. Copy it down. Now, in any given body, remember, in any given body, if number of protons Np is equal to number of electrons, then the body is said to be neutral. What does it mean? Net charge is 0, but mass is non-zero. So it is the mandatory. You have to understand, mass exists, charge may exist. Clear? But some people will say that wherever charge exists, mass will exist. Absolutely correct. But clear? Wherever charge does not exist, there also mass can exist. Clear?